Hello everyone, good afternoon. Dear authors and invited guests, welcome to Technical Session 2D. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you to the 6th International Conference on Information and Communication Technology for Intelligent System through Zoom. Further, as you are well aware, we have been facing new normal situation while overcoming the pandemic, hence the conference has been shifted to a hybrid mode. We hope you will enjoy the knowledgeable and interactive session through the day. We also hope to have you at future physical version of this conference. Also, there is a special note for the presenters. You will be given 7 to 8 minutes for the presentation and 2 minutes for the question and answers. On 7 minutes, I will raise a gentle reminder and I request while the presentation is going on, other participants kindly be muted. There is another request to all the participants that you all stay connected with us till the closing remarks. And just before we get started, I would like to introduce you all to the chair for the session, Dr. Chaya Jadhav. Dr. Chaya is working at Dr. D.Y. Patil Institute of Technology, Pune, and since 2001. Presently, she is working as an associate professor in Department of Computer Engineering. Her total teaching experience is more than 25 years. She has published more than 25 research articles in various journals, Web of Science, Springer, and SCI, international and national journals and conferences. She is a life member of professional bodies like Indian Society of Technical Education, Computer Society of India, Association of Computer Machinery, Institute of Electrical and Electronics Engineers, and International Association of Engineers. Okay, so I would like to start with our papers, and our first presenter is Shiva Krishna, and his paper title is Mass Student Attendance System Based on Facial Recognition and Machine Learning.
Sir, good afternoon, sir.
Good afternoon.
Actually, Shiva Krishna is our teammate, sir.
Okay.
Actually, he is unable to join. He'll join within another 2 or 3 minutes.
No worries. So you can do one thing. We start our next presentation. After that, you can present the.
Okay, okay, sir.
Okay.
Okay.
Yes, sir.
Okay, so our next presenter is Pavitra S, and her paper title is IoT-based smart baby cradle. A review.
Yes, sir. Am I audible, sir?
Yes, you
Yes,
are.
yes. You are audible.
Yes, sir. Shall I start my presentation, sir?
Yes, yes.
Yes, sir. Is it visible, sir?
Yes, it's visible.
Yes, ma'am. Good afternoon, one and all. Let me introduce myself. I am Pavitra. I am from M. Kumarasamy College of Engineering. My team members are Janani and Preeti, and we are guided by Telagmani ma'am. Our project title is IoT-based smart baby cradle, and our paper ID is 235. Thank you, everyone, for giving this opportunity to present here. The main objective of a project is that low cost which helps to the low cost, and also it helps to the working woman, because nowadays working woman has morely increased. The only disadvantages that women are facing is they are the only responsibility to take care of their baby, so it is difficult for them to take care of their baby and also doing their household work, and also along with this they need to do their office work too. So we have implemented this project, and then the sensors we have used in the project were a temperature sensor, presence sensor, pressure sensor, and then gyro sensor. The gyro sensor is a new feature which we have added in a project, which is not implemented in the existing project. We used canine application, which is already existing. We used it to share the data that we gathered by using the IoT. And then by using canine application, we can easily get the triggered message during when we are not with the baby, but also when we are around the baby, we can get the buzzer sound along with the baby's sensors. Then introduction, as we said earlier, parents need to be parents need to maintain their office work. Along with that, they need to take care of their baby, so it is very difficult for them. So this project helps to the parents to get their work. Along with that, they can do their office work, and then they can also take care of their baby by using internet of things. We have implemented the project. Internet of things is nothing but it is connecting through the internet. Even when we are not near to the project or object, we can also get the notifications. This is the proposed system of our project. By using Arduino ENO, we have used Atmega 328 for that. And then the temperature sensor, pressure sensor, and gyro sensor are in the input side. And then IoT, LCD, buzzer, and motor are in the output side. By using power supply, Arduino intake the data from the sensors and then get the output by using these sensors, by using these objects. And then by using the server, it explains about the IoT. It connects through the HTTP protocol to the app, and then it displays the result. These are the modules of a project. It collects the baby's data, and then first module is collect the baby data. We collect the data from the sensors we have mentioned before, and then checks whether the baby's condition is normal or abnormal. For example, if the temperature is less than 37, we have set that 37 as the default value. If it is less than 37, the condition seems to be normal. If it is higher than 37, the condition seems to be abnormal. And then the final module is that take required measures if abnormal. That is, if the for example, if the temperature is more than the expected temperature, that is more than 37, the fan automatically starts running to cool down the baby and also the surrounding temperature. And this is the flow diagram of a project. That is, when we start the project, it automatically connects to the internet and also to the mobile. After running the canine application, this is the flow of the project. First, the temperature is checked whether the temperature is high or no. If the temperature is high, the buzzer will start on and send the IoT message to the canine application. Similarly, the pressure sensor. If the pressure is high, then the buzzer starts running and the message will be sent to the IoT. If not, the baby is safe and the monitor baby condition via Arduino continuously and it will be end. Similarly, gyro sensor. Gyro sensor is nothing. Actually, gyro sensor is used to measure the baby's position. If the baby's position seems abnormal, then the buzzer starts run. And also, if the gyro sensor is seems to be normal, then the baby is safe, and then monitor, and it also monitor the baby's condition via Arduino, and this process seems to be end. It actually the end is not said to be completely end. This is similarly like a loop mode. When everything is checked once, it always checks regularly. And these are the software and hardware details that we have used. In software requirements, programming language such as embedded C is used. A compiler, which is Arduino IDE 1.8.3, and then a simulation is a Proctus. This is Proctus is used for the stimulation of the project. By using this Proctus, we can easily stimulate the project using the embedded C language. Hardware requirements: power supply, Arduino UNO, temperature sensor, gyro sensor, LCD, buzzer, fan and heater will be used. And thus conclusion. By concluding the project, I am saying that by using the project, we can make the working women more enthusiastic in their office work and also have their babies take care by their own. They no need any home or their grandparents help to take caring of their baby. It make them to self evaluate how strong they are. And then for IoT, it is used. We are using Node MUC to connect the IoT with the kit. And then thank you for giving me this opportunity.
Hello,
Yes, ma'am.
Pavitra.
Yes, ma'am.
Am I audible?
Yes, ma'am.
Am I audible?
Yes, ma'am. Hello, ma'am.
Yes. Yes.
Yes,
Can
ma'am.
you tell me where are you putting the sensors and all these things?
Ma'am, actually, we have made a kit, ma'am, not at a real-time project, ma'am.
Okay.
Yes,
So I
ma'am.
was thinking it is a real-time project.
No,
And
ma'am. It is a kit model, ma'am.
okay. And how you are measuring the baby's position and all these things?
Actually, gyro sensor is already used in the flight, ma'am, which is used
Mhm.
to check the flight's attitude whether it is correct or not. Similarly, we are similarly we are checking the baby's position is correct or abnormal, because due to abnormal condition, many babies are died, ma'am. When the parents are not aware of it, babies turn upside down, and due to breath loss.
Hello. Hello. Hello.
Ma'am, I think she lost connection.
Achha. Okay. Okay, sir.
Okay. So we start from the next presenter.
Yes, 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 yes.
Okay. So our next presenter is Shiva Krishna. Shiva is here.
No, sir, he didn't join yet. Shall we
Okay, no
proceed
worries.
with another
We start
presentation?
next presentation after that. You.
If he is unable to join by the next presentation, I will
Excuse me,
present, sir.
Okay, no worries.
Okay.
Excuse me, ma'am.
Yes, yes.
Ma'am, this is Pavitra, ma'am. This is my team member's ID, ma'am.
Yes, yes, yes. I got it, Pavitra. No issue.
I'm sorry, ma'am. Due to some security
Yes, yes,
connection, it got
yes,
logged off.
yes. We understood. Okay. Thank you for presentation.
Thank you, ma'am. Thank you.
Okay. Okay.
So our next presenter is Nilesh P. Sable, and his paper title is Pressure Prediction System in Lung Circuit Using Deep Learning. I think so. He also is not here. So we move forward for our next presenter. Will Pinwala, and his paper title is a survey on convolutional neural networks based on object detection methods. Okay, next.
I think he has not joined.
Yes, ma'am. So moving our next presenter, Deepak Upadhyay, and his paper title is Machine Learning Approach in 5G User Prediction. Deepak. Uh, okay. Ma'am, we start our next presenter.
Yes, sir.
He
Yes,
is
sir.
Sahil Khokar, and his paper title is License Plate Detection Techniques, Conventional Methods, Deep Learning. Dear presenter, you may please start your presentation. Sahil. I think there is a network connection.
Is there,
Hello.
is there any network issue, sir? That's why.
I think so. There is. Our next presenter is Neha Rupesh Thakur. She is not here. Is Rupon Kumar Ghosh is here? Ma'am, is that okay if we wait for 5 minutes to
Yes, sir.
for
No issue. We will wait for 5 minutes.
okay. Thank you. We have one presenter, ma'am. On behalf of Nilesh Popat Sable, Anjali Singh is here to present the paper.
Okay.
Should I start?
Yes, you can.
Yes, yes. Please start.
Hello everyone, I'm Anjali Singh. Today I'm here to present a paper on pressure prediction system in lung circuit using machine learning and deep learning. Our project guide for the same is Dr. Nilesh Sable. Our authors include myself, Anjali Singh, Onkar Vanve, Yash Hanbar, and Siddesh Wable. So during this presentation, we are going to go through the following contents. First, we're going to see the introduction, then the literature survey, what are the limitations of the existing system, the problem statement, our objective, system design, conclusion, and what references we have used. So as you know, when a patient is having trouble in breathing, the doctors put them on a ventilator. Now, what does the ventilator do? It pumps oxygen into a sedated patient's lung via a tube in the windpipe. So our project aims for mechanical ventilation control by machine learning. We believe that learning can research. During this, we went through various research papers, and few of those research papers are mentioned here. Now, as I said that in the industry, currently PID controllers are existing, and those existing systems have certain limitations. Few of them are mentioned here, like they are very intensive procedures, and developing new methods for controlling those ventilators is very expensive. In current simulators, they're actually taken as an assemble where each model simulates a lung system. However, lungs and their attributes form a continuous space. So a parametric approach must be explored that would consider the differences in the patient's lungs. Now, our problem statement is to use machine learning, neural networks, and deep learning to improve mechanical ventilation control and to generalize it across lungs with varying characteristics than the current industry standards of PID controllers. Our objective is to predict the ventilator pressure using machine learning model using the LSTM algorithm. We are aiming at predicting the pressure in respiratory circuit for different lung conditions and implementing the same project using web development. Now, our system design has following parts. We have divided the project into 3 parts. The first one is the data collection and analysis. In this step, the information is gathered from various sources and is processed to get useful insights from it. A second step is data modeling. In this step, the data objects and their relationship to the other objects are analyzed, data models are created, and the main aim is to find what data is needed and how we have to organize them. The third phase is deployment phase. In this, we are going to build, test, and deploy the project if you are satisfied with the above 2 procedures. Now you can see we have a flow diagram which indicates how our project is going to go. In this flow where we will retrieve the data from the data sets. Then we will process and prepare the data for the modeling purpose. We will then use machine learning algorithms to create ML models for it. Then we will process it for evaluation of model and we will tune the model to get better results. Once satisfied with this process, we will proceed to the deployment phase. Now, during our project, we are using some data that the data parameters used have been mentioned over here. We are using breath ID. This parameter indicates the unique ID for each breath. R attribute indicates how restricted the airway is, and C indicates how compliant the lung is. Time step is the actual time stamp, and UN is the control input for inspiratory valve. U out is the control input for expiratory valve, and pressure parameter indicates the respiratory circuit pressure. Now, this is the ventilator diagram which we are referring. In this block diagram of ventilator, here we have 2 systems. The first one is the inspiratory valve, and the second one is the expiratory path. The inspiratory path is connected to the regulated source of air and oxygen. These are the internal regulators which are used to reduce the gas pressure provided by the air and oxygen source to lower the level suitable for the ventilator. In this, you have the pressure regulator, inspiratory valve, safety valves, and filters. Safety valve actually sees if it is safe for the patient to send the air pressure at the level which we get from the inspiratory valve. Then this air from the inspiratory valve, it goes to the patient's lungs, and the exhaled air, it comes out through the expiratory valve. During the inspiration process, the inspiratory valve, it is left open and the expiratory valve closes down. And while the patient exhales, the expiratory valve is kept open and the inspiratory valve is closed. Now, in our project, we are using the LSTM algorithm. LSTM stands for long short-term memory. Pressure prediction is a type of sequence prediction problem. Sequence prediction is one of the hardest problems in the industry, and LSTM is found to be the most effective solution to such problems. LSTM has an over edge to the normal RNN. Now, why is it so? Because it is having an ability to selectively remember the patterns over long term. RNN is good for short patterns, but we have a lot. This is the block. This see 3 gates. One is the forget gate, then we have the input gate and the output gate. The input gate controls whether the memory cell is updated or not. Forget gate controls whether the memory cell is set to 0 or not. And the output gate, it controls whether the information of the current cell state is made visible or not. With this, we come to the conclusion. In this study, we saw that it proposed a machine learning model which has a high prediction accuracy, which is able to assist clinicians in decision-making process and contribute to develop new analytics to improve care at high technology readiness levels. We are still in the development phase of our project. These are the references we have used, which are mentioned here. Thank you.
Okay, thank you, Anjali. So have you taken database from where? Live database you have collected? Hello? Am I audible?
Yes, ma'am. Yes, madam. Can I answer the same?
Yes, sir.
Yes, sir.
Yes, sir.
Basically, we have taken the database from the open sources from IEEE. We have taken it from IEEE platform as well as from Kaggle. We have taken, and we have contacted one of the hospital from Pune. We can't disclose the name, but they are
Okay.
they have agreed for providing the database. So currently we are in the phase of what we can say development process. So once means final outputs are remaining. Till that we have reached now.
Okay. And which algorithm, sir? Machine learning
LSTM we are going for. Yes.
And have you considered, sir, the features, that is the age? What are the features you have considered for this?
That parametric evaluation is done. Like
Okay.
for example, the ages has been as you said, the what we can say, the division of ages has been done, and according to ages, which parameter affects the most, that has been categorized.
Okay.
Yes.
Thank you, sir. Nice, sir.
Okay.
Nice.
Thank you, ma'am.
Okay. Okay, sir.
Okay, our
Okay.
next
Thank you, ma'am.
presenter is
Thank you, sir.
Will Tinwala, and his paper title is on survey on convolutional neural networks based object detection methods.
Good evening. Am I audible?
Yes, you are.
Okay. Let me share my screen. A very good afternoon to everyone present here. My name is Vail Hussain Tinwala. I'm a final year BTech student at the Delhi Technological University. Today, I will be presenting our paper titled Survey on Convolutional Neural Networks Based Object Detection Methods. And my fellow authors are Shrishti Ronyar and Swapnil Agrawal. In this PPT, we'll be going over the introduction, the data sets, the literature review, conclusion, and the future work. So what is computer vision? Computer vision, or CV, enables computational systems to discern useful information from all forms of visual inputs and provide suggestions based on the data. Every day, there are millions of images that get produced and shared. Object detection is used to extract valuable information from these images for various different applications. On the right, you can see a figure of all the different object detection backbones that are commonly used. In this project, we have studied object detection methods and compared them with their baseline models. In our literature survey, we have presented a brief overview of the current situation of object detections. Now, from our study, we have compiled and collected some of the most commonly utilized datasets, the most popular ones being MS-COCO, Pascal VOC, and ImageNet. These datasets are the current standard for testing the capabilities of novel and improved object detectors and are used by all the state-of-the-art models. Coming to our literature review, we have studied over 20 different papers on object detection as well as salient object detection. These papers studied comprise the most recent developments in object detection as well as certain milestone developments from the recent past. The following table lists a very brief summary of these articles and lists their performance scores alongside each. Now, for a much more in-depth look into the literature review, you can refer to is mentioned in the paper that we have that we have published. Coming to our conclusion, due to rapid evolution of technology, specifically artificial intelligence and machine learning, automation has become one of the few fad words of the decade. A very significant role in this is played by computer vision tasks such as object detection, which is used in numerous cases such as security, detection, observation, image processing, etc. We learned from our literature review about various object detection backbones such as RetinaNet, ResNets, and ConvNets. There are different technologies, techniques, and strategies which are used for improving an algorithm, such as data augmentation, loss functions, feature extractions, to name a few. The graphs and charts above display the most commonly used practices in object detection. These base techniques are then improved upon by the above written techniques to push object detection algorithms to their peaks. Now, what does the future hold? Although object detection is a very hotly researched field, it still has a lot of potential. In the future, we are planning on implementing some of these models and architectures. We also aim to conduct a more in-depth analysis of each of these algorithms so as to have a significantly more comparable and reliable set of performance metrics. This would also allow us to quantitatively evaluate the widely different object detection methods on a similar level. With this, we come to the end of the presentation. Thank you. Hello.
Hello, am I audible?
Yes, ma'am.
What is the motivation behind selecting this topic?
So actually, initially we wanted to basically we wanted to do something in the field of object detection, but for all three of us, the three authors, this was the first time we were doing anything. So we did not know anything about object detection. So we thought, why not conduct a literature review, and that will help us gain an understanding of the field ourselves, and we can then go ahead and extend this review in the future and do some implementations and find some results.
This is a very vast area. If you want to further do the continuation, then you have to focus any one of that application.
Yes.
That can be done. Yes. Thank you.
Thank you.
Okay, moving forward for our next presentation is Deepak Upadhyay, and his paper title is Machine Learning Approach in 5G Users Prediction.
Yes, sir. Good afternoon, sir. Good afternoon, ma'am. Myself, Deepak
Good
Upadhyay.
afternoon.
I'm from Graphic Design University, Dehradun, MTech scholar. Right now, in my fourth semester of MTech from Computer Science and Engineering. My paper titled as the Machine Learning Approach in 5G Technology. I'm going to share my screen for the presentation. Is my screen visible?
Yes. Screen is visible.
Okay, so let me start. My topic is machine learning approach in 5G user prediction. So in this presentation, we will see the introduction, the methodology, and then data pre-processing, data representation predictions, performance metric, results, and then I will conclude everything with the references. All right. So let's move to the introduction. 5G is the latest generation of mobile networks, and it's a huge step up from what we have available to us today. The jump from 3G to 4G network was pretty huge. The 4G to 5G many times later, and almost difficult to comprehend. 5G is a entirely new kind of network designed to connect virtually everyone and everything together, be it smart devices, vehicles, and even industrial machineries. 5G will coexist with existing network till coverage is expanded significantly, but it will eventually evolve into a standalone network that operates independently. So the Internet of Things which requires ultra low latency network to work can only be achieved using the 5G generation of the mobile network communication system. In this way, we have used the Python for doing all the necessary predictions using machine learning algorithms such as logistic regression, random forest, decision tree, and XFP classifier. Using machine learning algorithm, the precision and accuracy of the particular algorithm has been tested. So This is the methodology we have used it data set for 5G and the pre-processing and data splitting and then testing the data, removing the target class, and training the data, building the machine learning model, apply in the written model, prediction result, and the return of the performance metrics. So we start the data pre-processing. In this scenario, the missing data is classified as unlinear, which is not at random, which simplifies the missing data is particularly connected to the what is missing. So the resulting data set was divided into training and testing data, with the training data accounting after 80% of the testing data and accounting for the leftover 20%. The train test split underscore method has been used by inbuilt library scikit-learn is used to divide the data set in the Python. So this is the data representation we have. Like we have a huge data set of around 1 lakh rows and 17 columns with like this in this figure. As we can see, the is 5G, a particular device is 5G or not, the density of 0 to 1000 has been seen, like with the density in the lower figure, like how what is the density and that particular density is 5G is or not. So the ratio is compared in this presentation. In this slide, you can see the data representation, data prediction. In the figure, the maximum density of is 5G appears to be 85, 81, 51, 31, 31 provisional IDs. Like you can see how the device ID is relating with the 5G or not, a particular device. Right. In this figure, we have seen like a 5G particularly depend on the channel type. Like what is the channel it is using, like hybrid channel, static channel, or dynamic channel. Which device is using which channel? So as for the data set on this prediction, we have seen the channel type, like which service type and which channel type is using, like 1, 2, 3, 4. We can see here the service types and the what that particular device is 5G or not. That is shown as is 5G. So in consideration of is 5G likelihood, service type of 5 is most prevalent across all the channels types from 1 to 10, as can be seen in the graph and the prediction. Moving forward to the next slide, we can see the data representation and prediction. In this slide, we have seen the product type. What is the product type of the 5G is, which product particular user is using, and in that product is using 5G or not, has been seen. Like we have product type of 2, 3, 4, 5, 6 different product types. In the consideration of 5G likelihood, product type 5 is most prevalent amongst all the channel types from 1 to 10. And in this representation, we have used the product type versus is 5G on the service type, like product type versus is 5G, that device is 5G or not, depending upon the service type, which service is using, like which band is using 2.4 gigahertz, 5 GHz, sub 6 gigahertz or the millimeter wave. In consideration of 5G likelihood, product type 5 is also the most prevalent amongst all product types from the 2 to 6, as it can be seen in the figure. And the prediction has been done successfully here also. Moving forward, it is the activity type versus is 5G sex type, like gender type. Like what is the gender of the particular person that is using the 5G in the device, like 0 for something else and 1 for some other gender. In the figure, this can be seen as activity set 7 is made by only one gender type, and it is the most common impact on the 5G. Like which activity is using by the particular user, and depending upon gender, that device is 5G or not. So it has been shown in this figure. Moving forward, it is component type. It is 5G or not. It is expire. Like sometimes we use the service and sometimes we have the service, but we have expired our validity. For that, is that expire 1, 2, 3, and that device is using 5G or not, and the component. In figure 8, it is exact type expired 2 is the most common across all types of the terms of 5G problem. In the figure 8 is the most common across the type of the 5G problem. And then moving forward to the next slide, we can see the term type versus is 5G in the max rate flag. Like here you can see what is the max rate flag. The most common across the each term type is 5G and can be seen in the figure. Moving forward, like age versus is 5G, like which age, like what is the age of a particular user using the 5G, and what is the age that 5G is being used at a particular age, and the gender you can see here. So the prediction has been made, like we can see in the figure, like what is 5G, like that probability and the chances of devices having a 5G or not, depending on the age of the person. The age column with the written problem is because the comprises 43 because of all the who have gender 1 that is higher than the gender 0, which is exception of age 59. As a result, it provides no new information to anticipate is 5G, and as it can be seen in the figure. So in this figure, we get city type, city level versus S5G. Like city level generally means like the what is the level of the city, like the level from level, and in that particular case, the elevation or the, we can say a particular city, like how much elevated it is. So that's also this thing. In this prediction, we have many the same as like different one on the gender type, and the prediction has been made. And the performance metrics of the channel comes down to be like this. When we have used the logistic regression, the accuracy was 0.99, recall was 0.99. We have seen the accuracy is true positive plus true negative divided by true positive plus true negative plus false positive plus false negative. Depending on the formulas, we have done we have maintained the performance metric of the prediction and the data set. These all are the and found to be in the next slide. In this slide, we can see the count of difference algorithm used, like how much correct prediction and how much the false prediction done by the algorithms. The decision tree, logistic regression, and the forensic and XGP classifier. So we can see here the logistic regression had made the zero false prediction, and while the decision tree is the worst amongst all, right? So this is the difference using the data set and different algorithm for the prediction. And the result can be seen here. In this, so we can see the results. Here, the logistic regression has the accuracy of 100%. XGP boost has the accuracy of 100%, while as the random forest has the accuracy of 99.7%, while the decision tree has a accuracy of 98 point something percent. Like experiment shows that the logistic regression and the XGP boost machine learning classifier perform well with the highest accuracy, whereas the decision tree comes at the lowest place amongst all. These are the references we have used for the research we have done and the prediction and the data set we have used. These are from quality journals and good conferences. Thank you. Thank you so much. Any questions?
Hello.
Yes, ma'am.
Deepak, for this, have you used a simulator or for results and all?
Ma'am, I have done this on Python, like on Google Colab. Python.
Okay. Okay.
Yes.
Thank
So
you.
our next presenter is
Thank you, ma'am. Thank you, sir.
on behalf of Shiva Krishna, Shweta presenting the paper on smart student attendance system based on facial recognition and machine learning.
Sir, good afternoon, one and all. This is Shweta Pesaru from Vignan Bharati Institute of Technology, Hyderabad. Today, I am here to present a paper on smart student attendance system. This is Shweta from Hyderabad. Today, I am here to present a paper on smart student attendance system using face recognition and machine learning. Today, these are the contents which I am going to discuss today. Introduction, literature survey, proposed system, methodology, architecture, and the results, conclusion, future enhancement, and references. The motivation for the selection of this topic is today's teachers' biggest issue is keeping track of their students' attendance. In all educational institutions, maintaining attendance is critical, and all the universities are allowing students to write their exams if they satisfy the minimum attendance criteria, that is above 75% in most of the universities and college. Every university or college has its system for recording student attendance. Some universities utilize a paper-based methodology, while others use automated fingerprinted biometrics. Nowadays, some universities are using this automated fingerprinted biometrics based on the Aadhaar. And this method and manual method, there are some of the challenges being faced by this by the existing system. If it is manual, then it is a wastage of time. Or for suppose if a teacher wants to teach a large group of students, there may be errors may occur, because the teacher may fail to check all the students, or else they may fail to call all the students. Okay, so this may be the reason they cannot give the attendance properly. So these are some of the drawbacks of the conventional methods of the existing systems. And here we have gone through some of the papers which are existing, that is attendance management system using biometrics, which was the authors of this paper are forms and have used a unique character each fingerprint or retina, for the biometric. And the disadvantages of the system, the advantages is they have identified it properly, and there are no outliers. That is, no one have gone out of the boundary. That is, they would have identified properly. But the cons is real-time implementation is difficult. The disadvantages are real-time implementation is difficult, and it is somewhat. If next paper, face recognition based attendance management system, the authors are Smita, Pavitra, and Afsin. They have used an approach called Navi based classifier. It is easy to classify, and the implementation is simple, but they could not achieve the results, proper results. That is because of the inconsistent method, because of the inconsistencies in the result. And the third paper, attendance management.
Ma'am, you are not audible.
Based on the facial. Okay.
You're not audible.
Beginning, I am not audible. Hello, madam. Am I audible now?
Now you're audible.
Madam, are you not able to listen from the first slide, madam?
No. Last 2 to 3 minutes.
Okay, there is
Some
network issue.
modification after Navy base.
Okay. Okay, ma'am.
Shweta, please share your screen and start again.
I'll share the screen again, madam. So here in the third paper, the advantages, effective classification has been done, and but the disadvantage is, since the data is large, they have a large data set, and it's time driven this method. So existing system, most of them has used skin color based extraction and classification. We have performed. We have used some algorithms. We have developed a model. We have proposed the proposed system has developed to address the problems of the traditional system. This paper intends to eliminate the paper effort and save time to obtain accurate attendance for students. The system has the most user-friendly UI, and we are able to generate efficient reports using the method. So whatever the method we have used is RGB and HSV techniques. Suppose if an image is given, what the proposed system does is it takes will give an image as an input. The input image can be obtained in various ways. There are two ways. That is, you can give the image directly. That is, by using camera, you can record the image, or else you, as the students are the students are common, or at least if it is a BTech degree, the students will last for 4 years. So we'll store them in a database. So we have used the second method, and as second method is efficient. Why? Because to capture the image every different. So we have used the second method. And in step 2, what we have done is we have used space.
Shweta, your slides are not. You're not changing your slides.
To extract the skin type. And
Hello.
And next step is there is.
Hello, Shweta. Hello. Hello.
Ma'am, I think she has some technical issue. Okay. Ma'am, shall we proceed to our next presentation?
Yes, sir.
Madam, sir, I'm presenting, sir. So just a second, sir, I'll explain architecture and I'll just move on, sir. So what I'm doing is we are going to capture the image and we are going to do the detection, and whatever the images we got, we'll do processing and we'll store it. And for so they want to extract.
Hello.
Yes, ma'am.
Sorry from my end, ma'am. There is a network issue. Hello, ma'am. There is a network. So here, what we'll do is we'll the
Your
resulting
screen
image.
is not visible, Shweta. If you could share
Now,
your screen
madam?
within 2 minutes.
Okay, just a second, ma'am. I try. Now it is visible, madam.
Yes, sir.
Yes. So what image will be captured and face detection algorithms like HSV and RGB are applied, and then feature extraction and classification is done, ma'am. So what I want to conclude is yes. So input image of an unknown face is given. Input image to a face vector, normalization is applied, and then a Euclidean distance is being used to convert the weight vector of an input image. And if the distance which we have calculated. So I conclude by saying that this is an efficient system uh, for tracking the attendance of the student, which will be useful in universities and colleges, sir. And the other thing is you can use them in offices also, corporate offices also, as well as in ATMs. You can use the same system, sir, so that you can more security, so that we can avoid thefts also.
Okay. Thank you. Thank you, Shweta.
Okay, ma'am. Sorry for the inconvenience. There is
Okay,
no
no
stable
issue.
internet connection.
Yes, yes.
Actually, I'm explaining the methodology, but you are unable to see that slide.
Yes, yes.
Okay, ma'am.
Thank you.
Thank you, ma'am.
So moving forward for our next presentation, Manish Sinha, and his paper title is Portfolio Optimization Using Reinforcement Learning, a study of implementation of learning to optimize.
Hello, hi. Am I audible?
Yes,
you are.
yes. You are audible.
Let me quickly share my screen. So, can you see the presentation, please?
Yes, yes.
Okay,
Visible.
so my name is Manish Sinha. I am from TCS Innovation Lab, and my focus is analytics and insights. In past, I've been associated with L&T Infotech and Bank of America, IIT Bombay, and Purdue University. And right now, presenting this part, the portfolio optimization using reinforcement learning. So, portfolio of an assets, I would say, is where everyone maintain their portfolio of stocks, be it any kind of stocks, maybe instrument, any kind of stocks or instruments like derivatives or something. And you have to make sure that your portfolio is optimized such that your returns are maximized. So in past, there are many various algorithms, such optimization algorithms. Here I mentioned like efficient frontier. If you could Google it out, you find that it's very famous algorithm where it's elliptical shape graph is there, and you have to come up with the maximum risks versus return trade-off. So the work has been done. That's what my intention is, that the work has been done in that area very much. And essentially, it is a you have to maximize the returns, and the weightage is comes out to be 100% of each stock distribution, right? So you have let's say X set of stocks and W set of weights across. Then you have to find the argmax W prime as such with the constraint as all the weights of distribution comes up to be one as a sum. So that's the problem statement. That's the objective function that I want to optimize. So while there are various approaches has been done to do that using genetic algorithms or other not, this is the reinforcement learning approach that we have taken. So it's a specialized part of machine learning where certain um, contributors to the maximizing the objective functions are agents, actions, states, environment, reward, punishment, and policy is one of them I have to mention here. So let me quickly show this. So it's a methodology, it's a standard agent and environment interface wherever you go for and see, look at the uh, reinforcement learning interface. So it's an agent which is trying to learn through a policy, and based on policy, the action is taken, and the environment decides the reward or punishment, and also provides the next step out of it. So in our case, our program is the agent, and it is trying to learn the policy. So the policy is to distribute the weightage across the portfolio such that the returns are maximized. So the action comes out of it is the weight ratios, and the environment is the set of the returns. So I'll come to to the environment, and then reward. So based on the reward of my weight ratio, I'll get the reward or the punishment, and then also the next state. So what is the environment first of all? So environment is a set of. So what I have done in this particular experiment, I have collected I have chosen 4 stock and got the historical data up to 5 years, and I calculated the returns. Right. So returns is the price formula, simple formula. Wherever you want to, you can find it wherever, and that return is the environment. So it's a set of historical data with the returns, and based on that, it will with the weights given by the action, it will decide that it has to give the reward or the punishment. So I've just described here the states. What could be the states? This set of stock returns is the state. So this is the return, and the set of that return is the state. What is the reward function? Weighted return calculations, environment, a set of states and rewards. Action is going to be the combination of weight distribution. I just said. Agent is the agent will accept the action if the returns are good. Agent will reject the action if the results returns are not good, or maybe negative or zero. So a policy to learn, I have chosen gradient descent, constraint gradient descent, but you can choose any deep learning algorithms also to understand it. So I think it is expecting the same thing, 4 stocks and the number of days. I have also calculated and comparison done against various other standardized optimization algorithm for this return calculation available in the world, and I have this is the comparison here. So most of the so you can see here some of the data of the weight allocations are kind of zeros, right? So what I conclude out of here is that these are so this is our approach, which is giving this distribution, and this is maybe other algorithmic approach. So what I concluded is that it's in general, if you are doing end of the day portfolio construction, end of the day portfolio optimization, then you can go watch for any other optimization available in the market, and you can utilize it. If you are doing algorithmic trading and you want to do in the real time, this approach will be well suited at because it's see at any point in time it is going zero, right? So anytime you have to sell the stock, it is saying, and then you have to buy them. So rather than that, you are descending towards that slowly, gradually. So it's algorithmic trading strategy that you are slicing the stocks buy or sell like that. So that is the thing. And takeaway is like pretty intuitive. If you want to look at the exact algorithm, it's mentioned in the paper. Real-time weight calculation. So it's a it's suitable for the algorithmic trading. So it's a fast learning. It behaves well in the historical data. Even you can create Monte Carlo simulations of the data and utilize to learn it and perform the actions. Yeah, that's me. The voice is hello.
Yes, yes. Yes, sir. Very nice presentation.
Thank you.
Shall we move for our next presentation, ma'am?
Yes, sir. Yes.
So our next presentation is K. Himabindu, and the paper title is Identification of Skin Disease Using Deep Learning Architecture. Dear presenter, you may start your presentation.
Yeah, I'm starting. Good afternoon, everyone present here. I'm K. Himabindu from Srinidhi Institute of Science and Technology. I'm here to present my paper, Identification of Skin Diseases Using Deep Learning Architecture. So we all know that dermatology is the branch that deals with the skin diseases. I mean, it is a branch where it classifies what kind of skin disease we have, and where we have doctors to diagnose our skin diseases. But skin diseases identification is a complex task because we have various by using with machine learning or automation, because we have various tasks like complexions, like color of the skin, and similarities between the diseases, and also the hair on the skin. Everything we have complex, but it is very necessary to identify skin disease in advanced stage, because sometimes this skin disease may be an symptom of a cancer. So if you want to, when you detect a cancer in early stages, we can get a cure, and we can get a cure properly. But if we detect it, diagnose it at later stages, it becomes a problem. So we, in order to go for it, we had to know what our changes in our body. So we need to know what happens in our body. But this identification of skin diseases becomes problematic in remote places, because India is a country where it has many people, many villages, 70% covered by villages. And the people without lack of knowledge, they continue that, they take it light, and they continue that that is an normal disease. So in order to reduce all this, and doctors cannot be available, I mean dermatologists cannot be available in every place. So in order to overcome all this, we need to develop a model, a computerized model, which is a computer can detect the images and say that so and so disease, you have got so and so skin disease. So we are in this world of automation. It is possible to develop such models. So my paper discuss about developing one model by using a deep learning techniques. These are the previous papers. These are the persons who already did survey on this skin disease. They used different type of architectures like mobile night, inspection R3, and got Saurav Kumar is the one who uses inspection R3 and mobile net architecture, and got 88% accuracy. His model is able to predict 20 skin diseases with 88 accuracy. And Parvatanini Nagashinvasu is the one who dealt with MobileNet V2 and LSTM and got accuracy of 85%. And we have other like AlexNet, Andrew Hong, who use AlexNet SVM and AlexNet KNN. He is capable of, his model is capable of diagnosing 4 skin diseases with accuracy of 85 to 90. In our model, we developed by using a deep learning architecture, that is AlexNet architecture. We have used collapse, and we all know that the deep learning is generally model is generally built by using the Python language. And the data set that we worked on is the ham data set, and this is the URL of that. It is an open source data set. These are the few images of that data set, from that data set. This is an
Excuse me, your slides are not changing. You are on the same slide.
okay, ma'am, just give me a minute. Can you see my slides now, ma'am?
Yes, yes. Now it's abstract. Yes, methodology. Yes.
Yes, ma'am. So
Yes.
I'll continue without my the slideshow. Is the slides are clear, ma'am?
Yes, yes. Slides are clear. Go to architecture.
Thanks, ma'am. So
Yes.
this is the block diagram. I mean, the steps we have performed. First, we resize the images. Next, split the data and train the model, and we perform the classification. We'll come to know in detail. The first step, first of all, whenever we work on any machine learning or deep learning, we need projects. We need to know the data. I mean, what kind of data we have, what can we take as the futures, what can we extract from that futures. We need to have that information. And later, as the ham data set is a data set with content 10,000 images. So a model to work on such large data set, it takes time. And AlexNet architecture is the one that works on a data set with a image size of 175. So we have, but the ham data set has 450 and 600 into 600 into 3 dimensions. So we resize that by using the resize technique. And later we use the AlexNet architecture to extract the futures and build the model to classify. Generally, the AlexNet architecture has total of 8 layers in common, in which 5 layers are the convolutional layers and the 3 are the fully connected layers. And we use the kernel filters to extract the futures from the images, and the activation function as the ReLU to remove the non-linearity. I mean, activation function is used to just ignite the neuron. I mean, if you want that neuron is working or not, this is the architecture. These 5 are the convolutional layers, and these are the fully connected layers. In convolutional layers, we do the resizing of images and we extract the images. We also perform max pooling in this max pooling in order to reduce the dimensions. Max pooling is nothing but we take a mask of any square mask, that is 3 into 3 or 6 into 6. We take a mask and we take the in case of max pooling, we can go for the maximum of the value in that pixels in that mask, and we can replace it with the highest thing. And the dropouts are used to reduce the overfitting model, and we go for the adaptive gradient algorithm to change the learning rates, because learning rates are the most important, because we iterate whenever we build a model, we iterate it by using an epoch. Here we give an as 150 times as epoch. So the model will train 150 times on the data. So we need, but if at all if the weights are that we give are wrong, then the machine will learn 150 times wrongly. So in order to reduce, to avoid that, we give an algorithm gradient, so that it will be capable of reducing the learning rate. I mean, the weights will be changed whenever there is an error. And later we use the mean squared error to remove any negative errors. And giving the epoch size as 150 and the batch size as 10, we are able to build the model, and the learning rate is 0.01. On building that model and training, we got the train accuracy as 90 and the test accuracy as 78.43. And these are the graphs we got. These applications of this model is capable of detecting the skin disease at the early stage. And the AlexNet architecture can train is the architecture that works well on images. And this model is able to, with the same futures, I mean that with the same learning rate and output, if you perform with the other architectures like RSNet, VGG, there was a gap between the train accuracy we got, it was higher, and the test accuracy. And the, so this model will be, we can also further develop this model into a mobile app which can be capable of detecting the diseases by just taking an image from your mobile. There are several, this model is able to diagnose 7 diseases that are present in the ham dataset. And these are the references we have, some of the references we have used. Thank you. Are there any questions, queries?
Have you completed this full project?
Yes, ma'am. We got the results in this.
Okay. And the database that you are used?
Ham data set, ma'am. I mean, we use a ham data set and we use Google Colapse as an interface.
Okay. Okay. Good.
Thank you.
Thank you.
Okay, so our next presenter is Sahil Hoker, and his paper title is License Plate Detection Techniques, Conventional Methods to Deep Learning.
Hello. Good afternoon, sir. Good afternoon, ma'am.
Good afternoon.
Um, are you able to see my screen now?
Yes, yes.
Okay. So my research has been on license plate detection techniques, and it has reviewed from where the technique started, that is the conventional methods, to the most recent deep learning models. Like, what is automatic license plate recognition system? So this system basically recognizes the number of a vehicle from an image or a video. Where it can be used? It can be used at tolls, in parking booths, or even with law enforcement agencies. There are 4 steps involved in the ALPR systems. However, it is not mandatory to use all 4. Sometimes you can skip the image preprocessing or even combine the character segmentation and character recognition part. So in image preprocessing, the major tasks are like grayscale conversion and noise removal and so on. Then the license plate detection part isolates the license plate of or the number plate of the vehicle from the entire image or video. The character segment step segments only the characters and leaves out all the noise from the license plate. And then the final step is character recognition, in which the segmented characters are recognized. So how it basically started was with geometric features such as height, width, aspect ratio, area, color of the license plate. Like we can all see that it's a rectangular thing with aspect ratio of about 1:4, and the colors that is black and white. We could isolate the license plate using these features initially. Some people also used the relative position of the license plate with respect to the tail lights, which are always red. This helped to increase the accuracy a bit. But there were several problems with the conventional methods. Like, it was not really robust. You had to think of every outlier case. Like if you were clicking from an angle, the rectangle may not be recognized. It's slanted, it's more of a rhombus. And the aspect ratio may change. It may be like 1:4 or 1:2. And the colors also, like there are blue license plates for diplomatic vehicles, yellow for commercial vehicles, and white and black for your normal vehicles. Also, it could not be deployed for real world applications. Then with the advancement in the field of machine learning, we started to use methods such as neural networks and SVMs. We had to provide these structures with features like what to look for. And some of the most important were like histogram of gradients, HOG. But these techniques were still too slow for real-time application. Then as computational resources become even more or less expensive and faster, and with the emergence of deep learning, the features that we had to provide to the algorithm were automatically extracted from the image by the deep learning architecture. Deep learning performs end-to-end learning. You just have to provide it with raw data, and tell it which task to perform, such as classification or detection. And from that, it can learn automatically. Also, its key advantage is it can be really robust depending on your data set, training data set. However, it requires a significantly large amount of data for training. So for our project, we used YOLO version 3 architecture for detection of license plate techniques. YOLO stands for You Only Look Once algorithm. It is a CNN-based one-stage detector using deep learning methods. We used Open Image Dataset version 6, which is provided by Google for training. But for testing, we used University of California, San Diego, and LDPRA datasets. We did something different from the rest of research, as usually people use the same dataset for training and testing, but just to check its robustness, we applied the testing and training on different datasets. And we found out that the algorithm is really robust, and also it can be used in real-time applications. Here are the results of the application. As you can see, we have achieved an accuracy of 95-96%. Also, the average processing time per image is 21.76 milliseconds, which comes to about, if you take in video terms, so it can process a video of 640 by 640 pixels at a frame rate of 45. And when we compare it with other methods, we can see that it has a great accuracy. The only other method that came close to it was faster RCMN, which is also a deep learning technique. However, its processing time was 70 milliseconds, which was too much to be used for real time applications. Okay, so that's been it. Thank you. Any questions?
Have you considered what type of plates, means English and all, or
Yes, ma'am.
nameplate?
We have only considered English nameplates because in most of the worlds, only English nameplates are used.
Okay.
Yes, ma'am.
And accuracy up till now you have achieved?
Ma'am, we have achieved overall accuracy of 95.38%. And this also when our training and testing data sets were different. Whereas all these other techniques use the same data set for training and testing. And as you can see, the color information and geometric projections, these are the conventional methods, and their accuracy was like 75%, 87%. With machine learning applications like SVM and neural networks, it surpassed the 90% accuracy, and with deep learning, but its processing time was like 3 seconds per image for SVM and 200 milliseconds for neural networks, which was just too much. But with deep learning, we have been able to achieve pretty much a good accuracy with reasonable processing times.
Good.
Yes, thank you, ma'am.
Thank you.
And so moving forward for our next presenter, Neha Rupesh Thakur, Smart Congestion Control and Path Scheduling in MPTC.
त्यांचं मंदिर आहे.
Neha is not here. Rupon Kumar Ghosh, and he's presenting on telecommunications customer experience prediction using hybrid machine learning model.
Can you allow me to share my screen?
Yes, you can.
Okay, thank you. Hi, can you see my screen?
Yes.
Hi, my name is Rupon Kumar Ghosh. I'm going to present telecommunication customer experience prediction using hybrid machine learning models. Thank you, Honorable CR, for allowing me to present. So this is the agenda of my today's presentation. Like, I would like to talk about the problem statement and objective of my research paper, and then how I did it. I'll talk in details. Also, I'll show the efficiency of the research. So as you know, this telecommunication industry is growing very fast, and their services are also becoming diversified day by day. And also there are so many telecommunication companies fighting with each others to survive, to make sure the subscriber experience is better. So in this circumstance, it is very much needed for them to identify the actual end subscriber experience in an efficient manner. And that's the key point where I have started my research. So every day we are using our network in different purposes. Whenever we are in in education phase, or we are moving to office, or anywhere. I mean, this is a must needed feature for our daily life now. So literature review, as you know, that this telecommunication data is not coming outside so that others can do the research. This is some sort of silo basis data. I'm working in a telecommunication industry, so I could get the data of subscriber level and the network level. And that's how there are not mass research paper on there for these topics. But there are two topics I identified for the customer sentiment analysis. But my topics is to identify the customer actual experience. So what was the problem statement of my research? Like, to identify the customer experience, to categorize the customer experience, is a customer is having a good network or is a bad network. And my main objective is to design a models so that we can easily identify that customer is having a good network based on his own usage data and also the network data. And we have used a couple of multiples machine learning algorithm to predict the customer experience efficiently. As you know, this customer, whenever me, you, and others are using the telecommunication network, this is the minimum data set we are generating continuously. Like whenever we are using the internet, we are generating clients internet related data. When we are using the voice call, we are generating the voice call data. And also eventually we are using the network. So whenever you want to develop a models to predict the customer experience, you have to use this subscriber generated data and also the network data. So this is the data set we have identified from the customer perspective. So how actually we prepare the data? First of all, as I am working in a telecommunication industry, I have taken 5,000 complaint subscriber from different channel, either from the digital channel or analog channel. And we have analyzed 7 days of that 5,000 complaint subscriber data, and eventually we have filtered those 5,000 subscriber based on different criteria, and we have chosen targeted 1,200 subscriber for this research. And after choosing the 1,200 subscriber, then we have collected the required data from the telecommunication core nodes. These core nodes and radio nodes, they are actually isolated nodes. So we have to follow some regulatory process to collect those data so that we can analyze them. And we have collected data on each and every category so that we are not missing any piece of data to identify the experience efficiently. And we have collected those data per subscriber basis, and we have collected more than 50,000 files from the different nodes. And also, beside the subscriber data, we have collected some telecommunication KPI. KPI means key performance indicator data, so that we can correlate them. We have collected network performance data with thousands of features from the mobile operator, but after analyzing them, we have identified that not all of them data are related with the customer experience. So we have selected only 8 features among them to identify the customer experience. One of them is client-side round trip time. This is related with your internet users. Another one is download throughput. This is actually directly involve your experience. And total connection failure means whenever you are trying to set up a internet connectivity, actually telecommunication system is giving you some parameter to identify that connection is set up or not. Then call setup delay is related with your voice experience. SMS is directly your messaging system. Call failure is indicating that you are finally set up the call or not. And call drop is indicating that you set up the call and eventually the call is dropped or not. And the last one, signal strength average, is giving you that what is your radio shifts strength with the particular telecom operator. So all of these 8 features I am using to train my model. So how my system is actually working. After selecting the data, I have identified, first of all, decision tree classified to classify the systems, to classify the eventual my target result. But after decision tree output, I identified that this data output is not enough. So I have considered logistic regression, support vector machine, neighbors, and then k-nearest neighbor classifier. All of this classifier I have used 5 times is. And finally, I combine them to a single classifier by max voting classifier, so that I can combine all of the 5 different classifier result to a single result set. And during this practice, I have used 60% of my input variables data for the for training the models, and 40% data to test the result set. And this is the proposed data structure. Like we are collecting data from the telecommunication node directly, and then we are training by 5 different model, and then identifying the result by max voting classifier. So to evaluate the system, I have considered 4 parameters like everyone do, like accuracy, precision, recall, and then F1 score. So in accuracy, my proposed hybrid approach actually giving me the best result like 97.50, and other model, 98.13, and other model like DT, LR, SBM, NB, and KNN, they are giving 97.50, 91.25, 92.50, 84.79, and 95.00. So based on the accuracy, we can identify that this hybrid approach actually giving the best result. And in precision also, the hybrid approach is giving best result like 98.93%. NB is showing up like 99.50, but based on the accuracy, we are actually selecting the hybrid approach. And in the recall value, our proposed hybrid system is giving 99.36%. Others are not giving exactly like 99.36%. So based on the accuracy and recall value, we can find that the hybrid approach is best. In the F1 score, also proposed model is giving 0.99.
Sorry to interrupt you, but you have last 1 minute.
Okay, so this is the result. And in the resource cost, we have run huge volume of data, and based on the result set, we identified that only 0.22 seconds is taking to process all the data and generating the reports. And in the conclusion, I can say that by our hybrid approach model, we can easily and efficiently identify the customer is having a good network from our system, from telecommunication services or not. And we have, after 1200 subscriber analysis, we have manually talked with the subscriber, and it was matching, the subscriber voice was matching with our model result. Thank you so much. Some are reference are mentioned here. If you have any question, please.
Ma'am, is there any question for the presentation?
Percentage of accuracy you received, sir?
98.13%.
Okay. Thank you, sir.
Moving our next presentation is
Good afternoon, ma'am.
Good
Am
afternoon.
I audible?
Yes.
Can I share my screen?
Yes, yes.
Is it visible, ma'am?
yes, it is visible. You can start your presentation.
Okay.
Yes, yes.
Thank you
Visible.
for the opportunity provided to me to present my paper on analysis of the various toxic gas levels using 5G machine learning IoT integrated system for air quality monitoring and forecasting. The main objective of my work is to measure the air quality, as well as we are taking major steps to forecast the air quality level for the forthcoming duration, and using that forecasting we could find out the ways in which we can provide sustainable development for reducing the air pollution. That is the major aim of this work. As an introduction, we can say that due to this growing population, there is a very great need for energy, and while they are using thermal or coal, burning the coal, some energy sectors are doing that, and also our road transport is the major source for air pollution, and major lung diseases are getting to fatal situation, and we could find that 27% deaths happen due to this air pollution. And even recent days in Delhi, we have seen that due to air pollution, the total environment is creating a lot of health problems to the people living there. And this risk of the health will lead to a lot of lung diseases and respiratory problems. And the main air pollution gases which contribute to this air pollution are carbon monoxide, sulfur dioxide, nitrogen dioxide, and ozone O3 gas. So we are using separate sensors to measure these gas level which is available in the air which is mixed in the air, and this the level of gases which is spreading into this air will worsen the situation, and they could provoke some chronic illness such as COPD and emphysema, and even lung cancer is also possible due to air pollution. So mainly we are focusing on artificial intelligence based machine learning approach to monitor the air quality and forecast what will be the air pollution in future as well, and how we can overcome such air pollution levels, right? So this is the major thing, and here the air quality index is going to be displayed by using a color graph, and the results are forecasting the air quality index. We are using separate sensors for each and every gas measurement, such as nitrogen dioxide is measured using 110.508 ND, and carbon monoxide is measured using 1684 ND, and carbon dioxide is used with measured using sensor SCD30, and ozone gas is measured using 1684 1040.
Not audible, madam.
Using a IoT model. Concentration of this gas levels is usually obtained as a data set from the satellite. The surface of the earth which is collected with this gas concentration is even obtained by Copernicus Sentinel 5P satellite, and we have observed 30 to 40 micromole per meter squared of nitrogen concentration in major cities of India, and carbon monoxide level is about 57 to 93 parts per million, and we measured sulfur dioxide threshold level. It is average of 100 micrograms per meter cube, and 0.1 parts per million of ozone gas exposure is recommended. And exposing the ozone level greater than 5 parts per million will lead to higher risk of health issues, and sometimes it may lead to death also. So the main objective is we are going to deploy a IoT system to monitor the air quality in the environment, and this is going to act as a physical layer. The physical layer device consists of the sensor, actuators, modules, and devices, and this data will be stored in the cloud server, and that is going to be using the network layer such as LAN and WAN. The information will be transmitted and it will be stored in the cloud server using the ThingSpeak network. And we were proposed to use this data and measure the forecast the air quality index by using the machine learning and AI tool. Using a MATLAB, we have tried this time. And this is the functional block diagram of the architecture. We have several sensors which is going to provide us with the data, and there is an actuator which is going to that is connect the module with we can talk in both the way. Actuators which can receive the data from the module, as well as it can connect it to the module as well. And the information which is collected by the module will be transmitted to a local area network or wide area network to the cloud server. We use ThingSpeak open access cloud server to store the data, and that will be used for analysis of the AI based machine learning tools. Here we have used the NARX machine learning using MATLAB. And the ThingSpeak channel data, which we measured from the various sensors, has been displayed through the graph based on the time and what is the level of each and every gas availability has been shown in various graphs here. And that is sulfur dioxide, and this graph shows regarding the carbon dioxide and the ozone gas level. Depending on the time, we could see what time the peak, during the peak hours, we could find the level of carbon monoxide and carbon dioxide and ozone gases more rather than in the morning time. So likewise there, difference in the level of polluting gases has been identified from the monitoring system. And the measured nitrogen dioxide and carbon monoxide has been shown in this graph. And we have estimated the PM 2.5 value using the machine learning analysis. We could see say that using this, we have found that when the level is between 0 to 100, the distribution of gas level, that is the pollution level, will be less. This is the amount of particles that are present in the air is measured. So the particles present in the air level, if it is lying between 0 to 100, it is minimum. The moderate level is when you are having between 300 to 500, will be having a moderate value. And it is above 500, we will be saying that that will lead to many health risks. So the particle distribution in the air is measured by using this PM 2.5 value machine learning analysis. And an average error in the NARX iteration has been shown here. This is nothing but your nonlinear auto-regression model with the external input data, which is available using your MATLAB. We have found the curve fitting analysis for various the average error that has occurred has been identified, and the neural network fitting curve shows that we'll be getting an average error, minimum error that could be available from the network has been identified for the absolute value, which is measured using this NARX iteration model. And using these things, we are finally about to conclude that the various measures of carbon monoxide, sulfur dioxide, nitrogen dioxide, ozone, and this particular matter level in the air, that is your PM 2.5 analysis we did. All those things has been measured, and the proposed technology uses the intelligent machine learning technique using neural networks to estimate the air quality index, and this provides forecasting of the air quality index for future as well. And from the obtained results, we have found that this PM 2.5 shows it is moderate for if it is moderate, few gases are present in the air, and if it is above the level, then it will be creating problems. So the forecasting analysis carried out by this machine learning model depicts that the air quality will be ruined for the next 8 to 10% level in the upcoming decade. So we have to take appropriate measures to reduce this level of air pollution that is going to be present. So we are exploring this pollution level and the hazardous level of air pollution, and the main aim of these results which we have obtained by this analysis is we have to benefit the humankind to know the level of air pollution and adopt some suitable development techniques to reduce the air pollution. And these are the references which we used for carrying out this machine learning approach and IoT integrated with machine learning.
Hello.
Yes, ma'am.
Have you considered any specific area?
In the sense, ma'am?
That means industrial area or some.
Ma'am, actually, we received we used the data which we received from the satellite information, and that is covering a major domain information. So we had a lot of input data for our analysis. We in future we were planning to monitor a particular domain area and compare with that of the satellite information as well.
Thank you, ma'am.
Thank you so much, ma'am. Thank you for the opportunity provided by this conference. Thank you so much.
So our next presentation is from Datta Yashashvi, and her paper title is an analysis on predicting social media ads using kernel SVM function.
So can we start presenting, sir?
Yes, you can, please.
Yes.
Please make it fast because we have running out of time.
Sure, sir. So, sir, good morning, sir. Sorry, good afternoon, sir. So, our topic is an analysis on predicting social media ads using kernel SVM function. So, you have to give a short brief about our paper. So, it's basically, sir, it's actually used for the e-commerce websites and the marketing. This is our actual application process, sir. So, we basically take the data sets from the websites. So the data sets contains your user ID, gender, age, and estimated salary and the purchase. So these are the attributes that we usually get it from the website. So we get the websites and we apply some particular algorithms for that, and we get the precision accuracy rate from that, so that the e-commerce websites can have an idea like to what users can we send some particular ads. So that would be a best solution. So that's the main brief about our paper. And these are the 7 algorithms that we have actually worked on it, and then where the comparison has happened. So the algorithms include logical regression, KNN, decision tree classifier, random forest, naive Bayes, and the 4 functions of kernel SVM, which include radial, linear, sigmoidal, and polynomial, as you can see it on the screen. And so yes, sir. So basically, we say these type of kernel SVMs is our novelty. So basically, for implementing of this kernel SVM and algorithms, we use a software called RStudio, and we apply this just by plotting out the data in the n-dimensional space, and further on we mine to discover the perfect hyperplane which separates between the 2 groups of classes. So basically, 3 steps has been done in any of the SVM is we actually start with the data based on low dimension. In this case, we would say our data is 2 dimensions, so we basically convert it to 3-dimensional data, and then we find the support vector classifier which separates the higher dimension into 2 groups. So basically, for that we need to create something called hyperplane, and these type of functions, say linear, polynomial, radial, and kernel and sigmoidal, these are actually something where they have unique formulas, and then they create a hyperplane which separates the 2 points. So if you have to brief about all of these, so we have just So these are the accuracy that that's been generated using the confusion matrix, and then we've just noted down all the true positive, false positive, true negative, false negative value, and the accuracy has been calculated. These are elaborated in the paper that we have submitted earlier. And then out of all the algorithms, out of all the 9 algorithms, we have found out that radial basis kernel SVM has given most accuracy of about 90%, wherein the already existing KNN algorithm gives 89%, and naive Bayes and random forest gives only 86%. So these are some of the graphs. So basically speaking, if we have to speak about sensitivity, we say radial kernel accuracy in terms of accuracy and sensitivity, radial kernel basis function actually gives the highest value. And then if I have to speak about FNR, we say polynomial kernel has the highest FNR value. And then in FN score, again the radial basis tops the list. And then in FPR, sigmoidal kernel just gives the best results.
So as Swati has said about all of this, then for the conclusion, sir, I can just say like a radial kernel SVM would be the best solution for for user for the e-commerce websites and all, because as we have seen in the graphs and also by that the table that we have formed, the kernel SVM has the better accuracy and precision value. We usually see for the accuracy and precision to market something or to generate to deal with anything that's socially. So that we would actually suggest radial kernel SVM, which is also a novelty in our paper, which haven't existed before, where we are using with the unique formula and all. So I can just conclude that radial kernel SVM is the better among all the 9 algorithms. And thank you.
Hello.
Yes, ma'am.
Have you compared with any other algorithms results?
Ma'am, we are compared with all the 9 algorithms that's showing in on my screen, ma'am.
The same data type, I used all the 9 algorithms, and we have found the accuracy for all the 9 algorithms. And it has come out to be that a radial basis kernel algorithm has the highest accuracy, map.
Okay, and database used for all this again, it will be same.
Yes, ma'am. The one which you have showed initially, this is the data source. We have got it. The user ID, gender, male, and the estimated salary. Kaggle, yeah.
Kaggle database. Okay.
Yes, ma'am.
Thank you.
Thank you so much. Thanks for.
Hello.
Okay,
Hello.
Moving forward for closing remarks, I sincerely thank our authors for their excellent presentation in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. All the presenters will be getting their digital certificates through email within 2 working days. Further, all the papers have already forwarded to the Springer. The publication will be live within 5 to 6 months. So kindly cooperate with the team of Team ICTIS 22. And I also thank our session chair, Dr. Chaya Jadhav, for chairing the session. And ma'am, here it's a token of appreciation from Team ICTIS 2022
Thank you,
and the
sir.
Global Knowledge Research Foundation.
Thank you, sir, for giving this opportunity. And all the papers were very informative and very nice topics were there. Thank you for giving these opportunities.
Thank you.
Thank you, sir.
And end of the session, I would request all the presenters to turn on your camera for the quick snapshot of the virtual conference. Thank you.
Thank you,
ma'am.
Thank you. Thank you. Thank you.
Shall I end the meeting?
Yes, ma'am.
Oh, thank you.